This is a disconnect. Disconnect keeps you safe, away from harm when you pull the disconnect. You put a lockout tag out on this and it keeps you safe from harm. This is a motor controller start station. You have your green button to indicate start. You have two contactors. This one right here, not touching, is called normally open. This one here is called normally closed. There's a red button. It's supposed to indicate a stop button. Same deal, normally open, normally closed. When I push this, it changes the state from open to closed, closed to open. Another push button, easy. There's a selector switch. When I go left, it goes down, left gets connected. I go right, goes down, right gets connected. And neutral position. That's the selector switch. Usually you do this for like auto, hand, or forward, reverse. Let's continue. This is your control relay. The control relay is exactly what it's told, controlling the circuit. If you look at here, it's a magnet inside. When the top gets energy, it pulls in, showing this coil. That's called the coil, that shape. A1, A2. A1, if you're doing 120 volts, would be your hot. A2 would be your neutral. 24 volts, this would be my positive 24, negative 24. If you notice here, this is a normally open, normally closed, normally open. You look in the front, it says normally open, NO, normally closed, NC, normally closed, NC, normally open, normally open. That is called a control relay. Let's continue. These are just plain old indicator lights. Basically just indicating something. This can indicate start for green, yellow for hand, and red for stop. This is a starter, a motor starter. They say manual because I can turn on and off from here. My power in, your power always goes to the top. That's what L means. Line 1, line 2, line 3. And the bottom is your motor, T1, T2, T3. This goes to your motor. When you close it, this inside closes a switch, activating power through this side. Okay. This is a motor starter, but it also has this symbol means overload, overload, overload. Overload indicates when a motor, it's specifically supposed to run at so many amps. When it gets past so many amps, or when it's hot, I've had it where it's been hot outside and still trip from that. The overload uses temperature to indicate and trip, keeping the motor from burning up. This is a manual motor starter. Let's continue. This is the controlled transformer station. What the purpose is a controlled transformer station. You put your high voltage here, 575, 600 volts, 23, whatever. High voltage here and low voltage out. The purpose of that is I want these controls to be low voltage. I don't want any high voltage in these. So I would, in some industries, it'd be 575 to 120, 575 to 24 volts. 24 volts is safe. We can work on 24 volts without getting hurt. This is called limit switches. Internally, is this physically done? So right now, in a relaxed state without power or movement, I am in the normally closed position, NC. Just like a light switch, on and off. When I push this in, it moves from NC to N open. Okay, so it comes off NC to N open. These are called limit switches. This is called different type of switches, more or less like when you run a machine in automatic or manual. So one thing is machines like a certain amount of air pressure. If you look in here, the air pressure is able to be set from 3 to 90 psi. All right, that's the switch, adjustable range up to 1,000. This is what you can put in here, right? You can put 6 volts, 12 volts, 24, 125, 250. That means I can switch it in here, okay? What happens is I apply this to air pressure. Machines where I used to work needs 80 pounds. So I set this up for, let's say, give or take 10%. I set it up for this. So if I don't have the 80 pounds, it's not going to run. This is the switch, normally closed, normally open. So when it gets to 80 pounds, it comes off of this and activates this. You can use this for two functions. One is to start, and when it hits this, you can say, hey, low air pressure. I'm using these two switches for two different things. This is like your sump pump. Your sump pump. The sump pump, same deal. This is a liquid level sensor. What it is, normally open until it hits, and it closes a switch, passing power. So let's say no sump pump running, water's filling, closed, I am filling. That is it. Now, I don't really work with this much, but this is called the drum switch. Basically, from looking at it, this is just to run a motor forward and reverse. That is it. Simple and easy. What it does when you run three-phase motors, just switching two leads reverses the motor in AC three-phase systems. Now, this is called the meat and potatoes of the motor. It's called forward and reverse coils contactors. Forward, reverse. Same thing as above there. I have my coil internal here, a magnet. It pushes it in. As it pushes in, this can't pull. It's interlocked. Can't push that in. That is called a start, forward, reverse. So the coil is hot with either 120 volts and then neutral, or 24 volts common, positive, and then 24 volts negative. Here's my switches, normally opens. With the interlock here, normally closed. Okay? This indicates when I'm pulled in, my motor's running. My motor's running. If you use that or that, depends on what you want to use. Okay? Now reverse is hit, same deal. I can't change state. It's engaged. That's what it is. Now, just like the one above here, this is an overload relay station. This can be used also. Just like the one you saw up there, I can vary my amperage to when I want it to trip. I can also test it. This one's not working. I can't test it. Test it. I can trip it. All right. So this, again, the motor, if it gets too hot, it protects it by opening these overloads. I'd rather have that than a burned up motor because it's so much harder to work with. You can use these to indicate to some kind of system that, A, my overload's not tripped. Oh, it is tripped. You can use this for that concept, overload. Now here's the meat and potato. It is the motor. This is a Y, as you see here. You have your T1, T2, T3. Okay, this is set two different ways. For low voltage, there's one way to wire it up. For high voltage, there's another way to wire it up. This is called the motor. Let me show you the motor. This is a Baldor motor. I use that a lot. Baldor motor. If you look here, this says low voltage. This says high voltage. Low voltage, probably at 230, which you see here. See, it says low voltage and high voltage. Low voltage 230, high voltage 460. Low voltage is showing that points 6, 5, and 4 are connected together. 9 and 3, 8 and 2, 7 and 1 are connected. This is where I put my leads, right here at this spot. 1, 2, 3. My leads get connected here, in here. That's all those wires are in this location. When I do high voltage, this is what I'm doing. 6 and 9, 5 and 8, 4 and 7, 3, 2, 1. These get wire nutted together, wire nutted together, wire nutted together, and my wires get connected to 1, 2, 3. That's if I have high voltage. This motor is a 0.3 horsepower motor. The amperage is 1.4 to 0.7. The higher amperage, that's why I'm showing, 230 is 1.4. Higher amperage voltage is 460 is 0.7. This is called the coupling. As the motor runs, the coupling drives something. Drives a conveyor, drives process, drives an elevator. That's what that's for. This is a motor starter, as you see here. This is what you would see in a PLC cabinet or a motor starter box. This is a trainer from Mtron, but I've also done this in real life. So any questions, reach out. My next episode, we'll be talking about dig deep into what's also in the control cabinets. For example, we have safety relays, safety processors, and etc. Thank you. Sean from Tech Training Solutions. Have a great day.